Hello, Cardinals. We're going to talk about investigation 5.1 today, plate tectonics. And our essential question is, how does energy from Earth's interior affect rocks in the crust? Before we do that, we're going to look back at yesterday's getting started where we talked about convection currents and we observed a fluid moving in a bottle after it was heated. And what you need to understand is that the core heats up the mantle above it. And because it's heated, it expands and then it rises and it creates convection currents, no different than what happens in our atmosphere that we studied in our weather unit. As those convection currents move, they tug at and pull along at the crust, causing continents to move together and continents to move apart, or even sometimes continents to rub past each other. So you need to understand that convection currents are caused by heat from the core, and that hot mantle rises and cooler mantle sinks, and that movement of the mantle is responsible for the movement of the continents. Looking back at our lab from yesterday too, this is what it should look like. You have trenches on the sides where the oceanic crust is subducting underneath the continental crust. You have a spreading ridge, and this is where the new material is being created. You have the convection cells. There's two of them. And then the lower mantle, which of course is heating the upper mantle. Today we're going to be using a PhET simulation. And the problem with that is it does not work on your Chromebook. So you'll be doing that in class using your school, your classroom, your lab computer. So we'll be working with partners. And if I exit out of here quick, you can see the PhET simulation looks something like this. All right, you have plate tectonics, and that should be up on your computer screen. If you happen to do this at home, maybe you can use your home computer if you have one. You're going to be using the book on page 121 to go through this, and it's just going to walk you through step by step, understanding things like oceanic and continental crust, understanding the temperature, the density, the thickness of the crust, and how that plays a role in the movement. So the first handful of questions are just understanding the crust, the density. The toolbox at the bottom is going to talk about density and temperature. And then you can move those tools up to the crust for questions 8 through 14. So you can monitor the temperature and the density of the crust as you manipulate the temperature and the thickness and the composition. For number 15, you're going to move on to the plate motion part of this. And then looking at what happens when there's continental crust, oceanic, or old oceanic and new oceanic crust. And then steps 17 through 20 are finishing up your lab. And then, of course, when we get done, we should read Building Your Knowledge, the Rock Cycle, and you will have a guided reading for that. So today, you'll be doing the PhET simulation. There's a student sheet 5.1 to place your information. And then when you're done, we'll be doing the rock cycle reading and completing your study guide. If you have any questions, please let your teacher know, and have a great day, Cardinals.